Welcome to our presentation, the Baja Steering Assembly.
The rack and pinion subsystem is designed after systems used on the real Baja cars. The rack pinion system also consists of 2 gears, a rack, housing, 2 bolt systems, and a connector. The reason for the 2 gears is to firstly make sure that the steering wheel has sufficient torque on the wheels, and 2, to make sure that the linear movement of the rack is in tune with the rotational movement of the steering wheel. For example, if the steering wheel is turned to the right, the rack must also move to the right. In order to make this system more efficient, some modifications were made to the design. One of the modifications is the fact that the housing on both sides of the system are identical. This allows for a more simple sub-assembly. One issue that we came upon is the gears and rack. To create the gears and rack, we used the toolbox to get custom gears and rack, which we modified to work better with our designs. Some of these modifications were the key insert made in the secondary gear and the extension and cut extrusion made on the rack to make it fit the housing. Because of these modifications, the sub-assemblies had minor issues working with the rest of the system. One of these issues was the fact that the rack and gear didn't load correctly into the original assembly. We fixed this by reloading the sub-assembly before loading the entire assembly. And when looking at the entire system, we had to make the rack and pinion's origin to the main assembly's origin, which allowed us to better simulate the steering system.
The steering wheel and the steering column linkages are what connect the primary mechanism of the rack and pinion to the driver. The design of the wheel is similar to most high-level racing applications. These frequently have only 2 handles, one on either side, saving space in the cabin and reducing overall weight. It also allows for a marginally clearer view of the dash itself and out of the windshield. This was attached to a steering wheel hub. This is for ease of connection to the steering column, as well as making the project more closely resemble systems found in real life. This hub is gear-mated to the column, which is typical for actual steering columns. The column is then connected to the linkage by way of the universal joint. These are mechanical connections designed to be able to transfer torque between 2 rods while allowing for movement in the angle between the rods. For the purposes of the steering linkages, however, this angle is constant. The universal joint is necessary to transfer torque from the column to the linkage at that angle. I attached the brackets of the universal joint to the column and the linkage using a simple pin. The 2 universal joint brackets are joined with a universal joint pin, which is shaped like an addition sign and allows for the 2 brackets to rotate around their respective arms of the pin. The plus sign shape allows for the arms of the pin driven by the column to twist the arms of the pin connected to the linkage. This whole system allows the torque applied to the steering wheel by the driver to make its way down and into the rack and pinion gearbox, ultimately causing the wheels to change direction and the path of the vehicle to change.
The ball bearing was created using simple revolve and circular pattern techniques. The ball bearing allows the wheels to rotate smoothly while minimizing friction. This happens because it allows the ball to roll instead of having 2 surfaces rub against each other. One interesting mate that I used was a coincident mate that connects to both the inner and outer ring so that the ball can rotate freely. A problem that I had with this assembly was figuring out how to create the cage. What I ended up doing was sketching and extruding a ring and then using a semicircle sketch and a revolve cut to make a hemisphere-shaped cut in the ring. Then I used a circular pattern to have that cut repeated for each ball. Finally, I mirrored the cage so that I can encompass both the sides of the ball bearing. I also used the toolbox rivets in order to keep both parts of the cage together. The wheel only consists of 2 parts, the first being the inner frame and the second being the tire. An issue of this assembly was with the inside frame part. The part would not extrude the middle of the wheel and would be giving me overdefined errors. I combated this issue by manually clicking each piece of the inside to extrude. There is also a cap at the center of the middle portion of the wheel so that the wheel mechanism can fit, since the end of the wheel mechanism sticks out.
The wheel mechanism is the part of the assembly that connects the tire and wheel rims to the rest of the Baja steering mechanism. Its main role is to help facilitate the motion of the tire. It swivels horizontally to allow the wheels to turn the vehicle. Some of its components are also able to rotate so that the wheel can spin. Some problems that I encountered when building the parts of the wheel mechanism mostly came from the knuckle. Its dimensions were very limited, and I had to calculate and estimate some of the distances using trigonometry. Also, the caliper and brake plate were not initially aligned during our first attempt in assembly, so we had to move a section of the knuckle that was connected to the caliper into the right place so that the caliper will be aligned correctly. Lastly, I had to apply mates to properly constrain the part so it rotated the way I wanted it to when the steering wheel was turned. Through the use of a distance mate and an additional part consisting of two long poles and a circle, the knuckle, and by extension, the wheel mechanism was able to function correctly. As you can see, the wheel is composed of several different parts through the explosion. And there's also the ball bearing, which is composed of several different parts. As we collapse them back together, you'll see how the wheel is able to spin and function through the use of the ball bearing. Once you zoom in, you're able to see how the ball bearing helps the whole wheel mechanism and the tires rotate.
Our next mechanism is the caliper, a device designed to slow down the brake disc and halt the steering rack. Our caliper was designed to be functional even without the braking system, which creates the pressure for the brake fluid. Instead, a piston was added which houses the brake fluid, so when force is applied to the piston, the brake fluid would be sent through the tube and push the piston into the brake disc. The issue that came was that force was lost when the fluid would split and go in opposite directions in the tube, so a spring was added to the caliper to compress and return the force back in the direction of the piston to provide it with more force. This gives the piston more force to push against the brake disc and helps stop the steering rack. Though due to the design of the steering rack, force must be added simultaneously to each caliper to stop the steering rack. The spring was created by including a virtual part into the assembly at the length of the distance between two parts, and then by matching the distance of the ring to that of the length, you can expand and decrease the size of it as the distance grows. The main issues with making the caliper was finding a way to make the caliper functional without the brake system. The other issue was just that the main bracket was too complex and took many remeasurements and redesigns to make a perfect fit with the brake disc and the main assembly.
Thank you for watching.